Let's explore the world of numbers. Not just any numbers, but special numbers. We're talking about perfect numbers. These numbers have amazed mathematicians for centuries. What makes these numbers perfect? The answer lies in their factors. Think of a perfect number like a perfectly balanced scale. When you add up all of its factors, except for the number itself, the sum equals the number itself. A perfect number is a positive whole number that equals the sum of its proper divisors. Proper divisors are all the positive whole numbers that divide evenly into the number, except for the number itself. Let's look at the number 6. The proper divisors of 6 are 1, 2, and 3. And guess what? 1 plus 2 plus 3 equals 6. This makes 6 a perfect number. Perfect numbers are rare and special in the world of numbers. All the perfect numbers we know of are even, and they are connected to something called Mersenne prime numbers. Mersenne prime numbers are the key to understanding perfect numbers. They are named after a mathematician named Mersenne. These prime numbers have a special form, 2 to the power of p minus 1, where p is also a prime number. If you calculate that and the result is also a prime number, you've found a Mersenne prime. Every even perfect number we know of can be written using a Mersenne prime number. Here's the formula. 2 to the power of p minus 1 times 2 to the power of p minus 1. This relationship is a very important rule in number theory. Let's uncover the hidden prime number p inside a perfect number. Perfect numbers are very special in math, and they have secrets waiting for us to discover. Imagine you're a math detective, and a perfect number is your crime scene. You need to find the clues hidden within the number to solve the mystery. Here's the formula that reveals p. P equals the logarithm base 2 of f divided by 2 to the power of p minus 1 plus 1, where f is the perfect number. This formula might look complicated, but we'll break it down step by step. It's the key to unlocking the secret of the prime number p hidden within a perfect number. In the next part, we will work through this formula and show that it's true using real perfect numbers. Get ready to see the power of mathematical deduction in action. Let's derive the formula for p. This will involve some cool and important math steps. Our goal is to get p by itself in the formula for an even perfect number. F equals 2 to the power of p minus 1 times 2 to the power of p minus 1. First, divide both sides by 2 to the power of p minus 1. F divided by 2 to the power of p minus 1 equals 2 to the power of p minus 1. Add 1 to both sides. F divided by 2 to the power of p minus 1 plus 1 equals 2 to the power of p. Apply the logarithm base 2 to both sides. Logarithm base 2 of f divided by 2 to the power of p minus 1 plus 1 equals logarithm base 2 of 2 to the power of p. Since the logarithm base 2 of 2 to the power of p simplifies to just p, we have p by itself. P equals logarithm base 2 of f divided by 2 to the power of p minus 1 plus 1. This formula lets us find the prime number p if we know the perfect number f. Next, we'll test this formula with real perfect numbers. Let's see if our formula works. We'll use two famous perfect numbers, 496 and 8128. We're going to put 496 and 8128 in for f, and see if we get a prime number for p. If we do, that means our formula is correct. Get ready to see how cool math is as we find the prime numbers hiding inside these perfect numbers. Let's start with the perfect number 496. Remember our formula, p equals the logarithm base 2 of f divided by 2 to the power of p minus 1 plus 1. We'll put 496 in for f. See how p is on both sides of the equation? To solve this, we'll try different numbers until we find the right one. Let's try p equals 5. When we put it in, we get 5 equals the logarithm base 2 of 32, which is true. That means 2 to the power of 5 minus 1 times 2 to the power of 5 minus 1 equals 496. Now let's look at 8128. Our formula is the same. P equals the logarithm base 2 of the quantity f divided by 2 to the power of p minus 1 plus 1. We'll put 8128 in for f. Again, we'll use trial and error. Let's try p equals 7. When we put it in, we get 7 equals the logarithm base 2 of 128, which is true. This means our formula found the prime number p for 8128, and it's 7. We've confirmed that 2 to the power of 7 minus 1 multiplied by 2 to the power of 7 minus 1 equals 8128. We used our formula to find the prime number p for both 496 and 8128. This shows how well the formula works in uncovering the hidden connection between perfect numbers and their Mersenne primes. Our journey shows how different math ideas are connected. This formula is a powerful tool for understanding how perfect numbers work. It lets us look inside these special numbers and find their prime building blocks. The formula we learned about is more than just a cool math trick. It's really important for number theory and how we understand perfect numbers. It creates a direct link between a perfect number and its Mersenne prime. This connection is super important for finding new perfect numbers. If we find a new Mersenne prime, we can use this formula to find its perfect number partner. Mathematicians are always looking for new perfect numbers. Our exploration of perfect numbers has taken us through prime numbers, Mersenne primes, and logarithms. We found a hidden formula that shows us the prime number p inside a perfect number f. We showed that the formula works using the perfect numbers 496 and 8128, finding their prime numbers 5 and 7. This journey showed us how different math ideas are connected. Each formula we learned about helped us understand the beautiful language of math. Keep exploring, keep asking questions, and you might discover amazing things in math. Don't forget to subscribe to our channel for more awesome videos about math and science. Thanks for watching.